Rain is one of nature's most essential and gentle processes. It nurtures life, refills rivers, sustains forests, and ensures the survival of billions of living beings. Yet we often take for granted just how precisely engineered this process is. Imagine for a moment a world where rain does not fall in millions of delicate droplets, but rather crashes down from the sky as one enormous, unified mass. This might sound like a scene from a science fiction film or a biblical-level catastrophe, but it is a theoretical possibility that scientists have explored. The consequences, if this were to occur, would be devastating beyond imagination. The scenario opens up a fascinating and terrifying discussion about physics, fluid dynamics, and the miraculous balance of our natural world. To understand what would happen if rain fell all at once, we need to examine how rain typically forms. Normally, water vapor in the atmosphere condenses into tiny droplets when it cools. These droplets group together around dust or pollen particles, forming clouds. Eventually, the droplets combine to become heavy enough to fall to the ground due to gravity. By the time rain reaches the earth, the droplets have achieved a terminal velocity, a constant speed where the resistance of the air balances the pull of gravity. This terminal velocity for a typical raindrop is around 20 miles per hour, 32 kilometers per hour. That's slow enough to be harmless and even pleasant to feel on our skin. But suppose this process were different. Suppose due to some catastrophic atmospheric anomaly, or perhaps an artificial manipulation of weather systems, rain did not divide into millions of small, manageable droplets. Instead, what if all the moisture in a cloud condensed into a massive sheet of water or coalesced into a few gigantic drops, and then fell as one violent surge? Suddenly, instead of soft rain pattering against your window pane, you'd experience a forceful slam, equivalent in speed and impact to a missile strike. According to scientists, a large mass of water falling from the height of rain clouds, typically around 2,000 to 5,000 meters, would accelerate under gravity to extremely high speeds if not broken into smaller drops by air resistance. Without the surface area to mass ratio that slows down individual raindrops, this water would hit the earth with unimaginable kinetic energy. Let's break this scenario into measurable consequences. If 50 massive drops the size of watermelons, each weighing several kilograms, fell at high velocity, the energy released upon impact would be comparable to that of a small atomic bomb. That's not an exaggeration. The kinetic energy, 1/2 mv squared, of these massive water blobs, descending at speeds of over 300 kilometers per hour, would unleash thousands of joules of energy on a very small area. The result? Craters, crushed vehicles, flattened buildings, and almost certain loss of life. This raises a haunting question. What if entire rain systems, spanning hundreds of kilometers, behaved like this? The level of destruction would be global. Farmlands would be torn apart. Urban centers would be riddled with water blast holes. Flooding would follow the initial impact, as the force of the water would break dams, burst drainage systems, and overwhelm rivers. The infrastructure of modern civilization, roads, bridges, power plants, homes, would be unable to withstand such concentrated kinetic assaults. Even airplanes flying through such phenomena could suffer catastrophic failures, as these masses of water would strike them like explosive devices in midair. Moreover, such rain would no longer replenish or nourish the soil. Instead of soaking gently into the earth, this sudden water assault would compact soil layers, erode topsoil, and strip land of its fertility. Agriculture, which depends on the gentle absorption of rain over time, would collapse under such extreme weather patterns. Crops would be destroyed in a single day, and replanting would be nearly impossible in the scarred and damaged land that remained. Beyond the direct physical destruction, the psychological and societal consequences would also be profound. Humans are deeply tuned into the rhythms of weather. We find joy in light showers, comfort in the coolness of drizzle after a hot day, and romance in the sound of raindrops. If this turned into a source of fear, where every time clouds gather, people would run for shelter fearing an apocalyptic downpour, life as we know it would change. Cities would need to be redesigned with bomb-proof ceilings or underground living spaces. Emergency alert systems would have to evolve to detect mass waterfall events, Insurance companies would likely collapse under the weight of claims. Mental health issues like climate anxiety and meteorophobia, fear of weather, would skyrocket. Let us also consider the environmental toll. Such high-impact rain events would disrupt ecosystems in ways we cannot fully predict. Forests would be smashed. Birds and small animals, unable to shelter or outrun the impact, would perish. Rivers and lakes might overflow and change course, killing aquatic life and destroying delicate habitats. The water cycle itself could become destabilized. The very mechanism that supports life on Earth would become a weapon against it. But thankfully, none of this happens. And that is what makes this discussion not just a horrifying what if, but also a powerful reminder of how finely tuned the natural world is. The fact that rain falls in droplets is not random. It's an extraordinary balancing act governed by the physics of fluid cohesion, air resistance, gravity, and atmospheric pressure. When water droplets fall, they reach a terminal velocity that is slow and harmless, thanks to their small size and the friction of air molecules. The droplets tend to stay small because surface tension prevents them from growing too large in clouds. If they become too big, they break apart as they fall. This self-regulating process ensures that no drop becomes a deadly projectile. It's also worth appreciating the engineering marvel this presents from a biological and evolutionary standpoint. Plants have evolved to benefit from rain that doesn't crush them. Leaves are structured to guide water toward roots gently. Animals have developed fur, feathers, and behaviors that manage moderate rainfall. Human beings have built entire civilizations based on the reliability and gentleness of the water cycle. We can grow food, live in exposed environments, and develop cultural traditions around rain, like dances, poems, festivals, and art, all because we are protected from the deadly consequences of mass water impact. Now imagine applying this understanding to technological design. If engineers were to replicate a system of water distribution from a height, say for firefighting drones or artificial irrigation systems, they would need to mimic the droplet form nature uses. A burst of water from a high-altitude drone would need to be broken into mist or rain-like droplets to avoid damaging crops or causing accidents. In a way, nature has already figured out what humans still struggle to master: the perfect balance between energy, speed, and sustainability. Scientists have even taken this concept further into planetary science and speculative futures. If humans were to colonize Mars or terraform other planets, replicating Earth's rain system would be crucial. Not just the moisture, but the droplet size, falling velocity, and absorption rate would need to be engineered with extreme precision. Otherwise, the settlers could face destruction from the very thing meant to give them life: water. The same applies to futuristic Earth-based climate interventions, like cloud seeding or weather manipulation. If these are not done with absolute understanding of natural water behavior, the consequences could be devastating. This theoretical catastrophe also has educational value. It can be used to teach children and students the importance of physics, atmospheric science, and environmental engineering. What sounds like a simple question, what if rain fell all at once, opens up entire fields of scientific curiosity. It forces us to understand terminal velocity, fluid dynamics, cloud condensation nuclei, gravitational acceleration, and environmental resilience. It connects science with storytelling, helping people see the wonders of nature through the lens of imagination and analysis. Perhaps the most profound takeaway from this entire thought experiment is one of gratitude. We often look at natural events as mundane because they occur regularly, but regularity does not mean simplicity. Rain in its current form is a miracle of balance. It is gentle enough to fall on a child's face without harm, yet powerful enough to carve rivers and shape valleys. It brings life without taking it, and it's easy to forget that it could have been otherwise. Nature didn't have to work this way, but it does, and that is the true marvel. As we move forward into an age of climate uncertainty, this thought experiment also becomes a warning. Human influence is already altering weather patterns. If we continue on paths that destabilize the atmosphere, whether through excessive greenhouse gas emissions, deforestation, or reckless geoengineering, we may inadvertently trigger changes we do not fully understand. While it is unlikely that rain would suddenly fall in singular masses due to natural causes, we should never underestimate our potential to disrupt even the most fundamental natural systems. In conclusion, the scenario of rain falling all at once, rather than in gentle droplets, serves as both a cautionary tale and a celebration of nature's brilliance. It shows us how something as ordinary as a rainy day is, in reality, an incredibly sophisticated event, delicately balanced to support life rather than destroy it. The next time you step outside and feel a raindrop on your skin, remember, it could have been a missile, but nature chose mercy, and that's worth cherishing.